So now it's time to conclude S3 section 1, but before that, a concluding remark which will be done using architecture using S3. So these are the services that uses S3 to do processing in some sort of data engineering or the other. So for example, Athena actually reads data only from S3, and there are other data sources that can Athena connect to as well. But primarily, Athena does processing on S3. So select statement on S3 objects. Same is the case with Redshift Spectrum, which reads data from S3 objects or files or folders. And if we are running a distributed processing framework like Spark on EMR, we can mention S3 as the data source because S3 is again a replacement of HDFS for Spark. Glue is also a managed service for Spark. Then you have Kinesis Firehose, which reads data or gets data from Kinesis data streams and then stores them in Spark. Same is the case with AWS DMS. And we can run Presto on EMR also, which can read data from S3. And we can use S3 to store edge-based tables also. So again, the list is not exhaustive. There are third-party tools also like Snowflake, which can use S3 as well. There's Databricks, which can use S3 too. So there are a lot of usage of S3. Now the architecture would be similar to the data pipeline. At the center, we'll have AWS S3 storage. And after that, on the left-hand side, we'll have the data generators, and on the right-hand side, we'll have the data consumers. The architecture diagram combines both data engineering applications and normal applications. So let's say I have OLTP data sources like RDS or Aurora or DynamoDB or DocumentDB or MongoDB, etc. We can read data from these OLTP data sources using DMS or Debezium or other tools like Stream, etc. and we move data to S3. So these are data that are used as input for the analytics pipeline or data engineering pipeline. Now DMS is not the only option. We can export data from OLTP data sources also, like Aurora provides a feature to export to S3, DynamoDB also provides, and likewise there are other databases also. Not only that, we can import data from S3 also to load the tables which are there in the OLTP data sources. So let's say the data is being stored using something like Kinesis to S3 and then using import to import those records to Aurora MySQL tables or DynamoDB tables. So in that case, we can use import option as well. Then we might be having streaming applications which will stream data to Kinesis streams, or it can stream to Kafka also. From Kinesis streams, it will go to Kinesis Firehose, and from there it will go to S3. From Kafka, we can use Kafka consumers to store the data in S3 also. So these are the various streaming applications. Now, not only that, we can use stream processing framework like Spark Streaming, Flink, etc. to do the processing from Kinesis and Kafka and store it in S3 also. Then we have other applications like media applications which will upload data directly to S3 like Netflix, Amazon Prime, etc. We might be having social media applications also like Twitter, Instagram, Tinder, etc. wherein whenever you take a photo and upload, it might be uploaded to S3. And there can be a lot of other applications which might be uploading PDF documents, Excel files, Word documents, etc. So these are the various data generators or sources of data from or to S3. So now when the data comes to S3, of course, the data has to be consumed. Now I'll start with data engineering again. So the first thing is that we want to move data to, let's say, Redshift. So from S3, we can use this copy command to load data to Redshift tables. And we'll see this in the Redshift chapter also, that we can use this copy commands to load records from files to Redshift tables directly. We can query the data that is in S3 using Redshift Spectrum also, which basically points to a S3 location, and then you can run select statement on top of it. We might be having other tools like Glue and EMR. So Glue runs only Spark jobs, but EMR can run open source technologies like Spark, Hive, Presto, Flink, etc. And they can either read from S3 or write to S3 also. Then of course we have Athena. The primary utilization of Athena is to read data from S3 using SQL. And by the way, Athena is written on Trino, which is an advanced version of Presto. Then we have other consumer applications like BI tools, reportings, or other semantic layer, which will read data directly from these different data sources. We might be having video applications also, which will do video transformation. So it will read the video that have been uploaded by media applications and do some transformation and then upload it back to S3. Now, when I talk about video transformation, it means transcoding or encoding. Let's say when you look at any video from Netflix or Amazon Prime or YouTube, what you see is that you can change the pixelated view. So it can be HD, it can be 1080p, it can be 970 or 920p, 720p, etc. So those are video transcoding, and let's say the media applications are uploading the video, and we have a application, or we have a processing layer which will read the videos and transcode them and put them back to S3. And after that, the OTT platforms will read these media files and show them to the user, of course using some media players. So this is what I was talking about. Now after your application puts the data back to S3 using video transcoding, then we have OTT platforms, which are basically the media applications, the consuming layer of the media applications. They will read these files and show it to the end user using a media player. Then we can have social media applications also, like WhatsApp, Instagram, TikTok, Twitter, etc. And we can upload and download files using these applications. Again, a disclaimer, this is not an exhaustive list. The use cases of S3 might be way more than this. And these are the major use cases that you can think of. And the top portion that you see here is the data engineering part, and the bottom portion is typically the normal application part where S3 can be used. So the utilization of S3 is very, very high, and it's a very critical layer for data engineering pipeline, and it's a very critical service not only for data engineering, for other applications also. So this concludes S3 section 1. Thanks a lot for tuning in. Let's move to the next section of S3.